Oh, karena ini di-record, nanti kan teman kalian pasti mau nonton juga ya. Jadi in English aja ya. Nggak apa-apa kan?
Iya, nggak apa-apa, Mas.
Oke, aku mulai ya. Good, apa? What time is it? Good afternoon, everyone. So I'd like to start the class for chapters 2 and 3. Chapter two, we will be discussing about kinematics. Kinematics. Is anyone here familiar with kinematics? Does anyone know what kinematics means? If you know anything about kinematics, please raise your hand. Raise your hand in Zoom, yeah, not in real life.
Di sini tuh di dekat tuh banyak ada.
Anyone know what kinematics is? Yeah, Rafa.
So, kinematics is the branch of mechanics that talks about the motion of the object without talking about the cause of the motion.
Yeah, yes, that is very correct. Please write your name and NRP in the chat room so I can list it. Yeah. So basically, when we're talking about kinematics, we just want to analyze the motion of an object, not what causes the motion. So for example, it's like a parabolic motion. We just want to know like how long does it take to reach the highest point? How long does it take to reach to fall down again? But we're not really looking at like what force is making this movement possible. So before I start, does anyone know anything about parabolic motion? What is a parabolic motion? Like what uh anything you know? Just raise your hand and say what you know. It's a simple question about parabolic motion. I'm 100% sure that most of you are familiar with parabolic motion. Okay,
Right. So the question is about parabolic motion, right?
yes.
And like when you're throwing something, it will go back to the ground with like with the circulating motion. So is it right?
Yes. It's yeah, I could say it's correct, but parabolic motion easy, it's just a motion that makes a parabola gini. Sebuah gerak yang membentuk parabola. Or if you want to memorize it easily, basically half a circle. Now, to get into the physics of it, we know that in parabolic motion, there are two uh, two directions of motions. There's direction towards the x-axis and the y-axis. Now, motion on the y-axis is is under the influence of gravity. That's why this motion it will be non-uniform motion, atau kalau kalian lebih kenal itu GLBB. Now, if we talk about the x-axis, the motion is constant. What I mean by constant is the initial x-axis velocity will be equal to the final velocity. Any questions? Oh, this is uniform motion or GLB, if you're familiar with it. Any questions? Okay, I'll continue. Now, when we're talking about parabolic motion, the formulas will be similar to the formula you use in GLBB, non-uniform motion. See, if in non, I'm gonna erase this. Can I erase this, my annotation? Or are you guys taking notes?
You can repeat it.
Wait. Okay, now. Do you guys still remember the formula for position in non-uniform motion atau GLBB? Let's do it on this one-dimensional scale. So let's do it on the x-axis. Does anyone remember persamaan GLBB untuk posisi? Now, if you look to the left, this one, it's very similar to this, but usually in one dimensions or only the x-axis, what's the x-axis movement, we can state it as x0, x0 plus initial velocity multiplied by time, add it with acceleration times squared over 2. It's very similar, but on the only difference is this, because of the direction of gravity. And since we're looking at this on the y-axis, we're looking at the initial velocity on the y-axis, and the initial position is also on the y-axis. That's the only main difference. It's the same for the other formulas, like this one. If you guys remember the formula, it should be Vt, or final velocity, is equal to initial speed plus acceleration multiplied by time. So I already listed the common formulas here. I will share this later, the notes. See this formula right here. It's for, what's it called? The maximum x position, or point C. See this one? This is for point C. And this is for point B. Point B is for max y. At the maximum height, your speed, your velocity there will be 0. That's the same for what's it called? Vertical motion. So basically, if you throw a ball up at the maximum y level here, the velocity will be 0. It's basically the same like that, but on a two-dimensional scale. Before I continue, are there any questions? Okay, I'll continue. Next is rotational motion. See, here's the thing. You guys already know about non-uniform motion and uniform motion, GLB and GLBB. The thing is about these things is that the formulas are nearly identical. Sometimes the only thing you change is the symbols or the plus and minus values. That's the same for rotational motion. See, if you check the formulas here, they're all the same. The only difference is that the symbols, like this is for this, this is angular velocity. This is for, yeah, the angle, basically. It's basically the same, it's just a different symbol. But you still have to understand it. See, this is rotational motion. I have to explain this a bit. So in rotational motion, you will have tangent acceleration and centripetal acceleration. So does anyone here know tangent acceleration and centripetal? Ada yang tahu nggak? Oke, please answer.
Tangent acceleration is the acceleration going outside the circle or going straight, and then the centripetal acceleration is the one going to the center of the circle.
Yes, that is very correct. As you can see from my not so good drawing, it basically makes this. Let's say this is the tangent, this is the centripetal, and this is total. Now, if you guys still remember Pythagorean theorem, it's easy to get the 8 total since you know this. This is just the tangent, and this is the centripetal. And you just use Pythagorean's theorem, or actually, yeah, it's just this one. Any questions? Oh, and please do note that for tangent acceleration, it is only present when we're talking about non-uniform rotational motion. So basically, there's percepatan angular, angular acceleration. Where is it? There. Alpha. So if we're talking about uniform rotational motion, there will be no such thing as tangent acceleration. Any questions? Okay, if there aren't any questions, I have some exercises for you. Wait, I'm gonna share it after, I have to find it first, my screenshot. Okay, give me a second, yeah. Here. Can you guys see this?
Yes.
Okay, so I will give you 5 minutes to do this because it's not very hard. But if anyone wants to try right now, please do. Ten minutes there. I'll give you 10 minutes. If you have any questions, raise your hand. Actually, I'll draw it for you, but later when you have an exam, you'll have to draw it yourself. I'm just gonna draw it to you so it's easier for you to do it now. I'll just do it here. Let's say it's a stick man. And he throws it. If this is 45 meters, and this theta is equal to 30 degrees. and there is an initial speed of, what's the initial speed? The initial speed is 20 meters per second. Now I'll give you one clue. You will be using the formula I gave you earlier. The y is equal to y naught plus, this is the formula you will use. But first you will need this. Oh, and I don't I don't think I should say this, but I think it's gonna confuse you, but I'll just say it anyway. There are two point of views for this exercise. You can set it like this. This is equal to 45 meters. Or you can make it like this. Now, what's the difference? For this one, you will take this point as 0. But for YF equals 45, what happens is you take this as 0. It's gonna give the same answer, but it's good to have two point of views.
Can I ask? Mas,
Ya, kenapa?
so the gravity is 10 or 9.8?
Just use 10 deh, 10.
Okay, thank you.
Has anyone got the answer yet? Is anyone confused?
Cos
Anyone done it yet?
Is it 4.16 second?
Yes. Can you show your work? Wait. Just send a picture to the group, and I'll share it. Yeah. Okay. So yes, this is the correct answer. Basically, what's gonna happen here is you're gonna get as you can see in, what's your name? Sorry. Hello. Okay, as you can see in your friend's work, you will get a quadratic formula. This form was quadratic formula. You have to solve it using this. The solution for the quadratic equation, or if you're familiar with it from high school, di Indonesia itu rumus ABC. Basically, minus b plus minus square root b squared minus 4ac over 2a. You will get two values of two solutions, basically. Sorry. And as you can see here, this is the real solution, 4.16 seconds. But if you get another T2 will be equal to minus blah, 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 blah seconds. This is not a solution you will use. Or you can just say it's undefined and you can just use the positive one because there is no negative time. Can you write your name and NRP in the chat room, please? Okay, thank you. Okay, now for part 2 of the question. Part 2 is actually easier. So for the second part, what I want to know is, sorry, someone's outside my room. Wait, I'm gonna change my share screen. Sorry, my laptop is weird. Can you guys see this? Yes, okay. Before I give you a clue on how to do this, does anyone know how to do it without me giving a clue? Anyone know? Using the formula Vt squared equal V naught squared plus 2AS. You try it. But that's not the form you're gonna use. You have to convert that non-uniform motion to parabolic motion. So basically it's gonna turn into this. V naught y squared minus 2GH. Now, from this formula, so you know this and you know this. So you're gonna get this. So it should probably work. Then later you have to find this, which is equal to this. And to find the V, what you have to do is take this. VTX squared plus VTY squared. Can anyone do it? Coba Rafa. Yeah. It should be easy. I already gave you a lot of clues for this one. Have you guys done your quiz yet?
Yes, we have.
How was the
We had
grades?
one. Uh,
So if anyone has done their work, just send it to the group yeah, and I'll review all of them. So if you've done this, just send a picture and then I'll share it to the class. Yeah. So how was your quiz, guys?
Cukup suram, Mas.
Suramnya gimana nih? Udah ada nilainya. Did you guys get your grade yet?
Sudah Mas, sudah ada nilainya.
Berapa?
Kurang memuaskan Mas.
Normal lah kayak gitu. Emang berapa kurang memuaskannya masalahnya?
Pokoknya kurang banget. Sumpah, soalnya tuh sulit.
Did you pass at least? Is it above 56?
Seperti
Waduh,
itu, Mas.
Kurang sepatu.
Nggak apa-apa, kita semua pernah kayak gitu. Ya, aku share yang pertama ini dari Ardino ya. Wait, aku save dulu ya. Stop share. Print aja deh. Vy squared is equal to v null y squared minus 2gh. V null y. Okay. You made a slight mistake. See, v null y is not 20. The initial is, it should be 20 sine 30. I think that's, so it should be 10. See, here it's still 20. And okay, how did you get this from 300 to 17.3?
Iya Mas, itu saya ada salah tanda, harusnya harusnya nggak segitu Mas. Salah-salah parah itu Mas.
Nggak apa-apa, ditulis aja nama NRP-nya ya.
Oke oke.
Nggak ada pengurangan nilai ya kalau asistensi ya, santai aja. Cuman penambahan. Oke, next. Wait ya. Okay, up to this point, so I have to zoom it first. Up to this point, you got the Vy, which is correct, but you also need Vx and V, which you should already know. Vx is just V null cos theta, and V is just this. But up to this point, this is correct. You're just not finished yet. Yeah. Anyone else? Actually, guys, can you write your name and NRP in our WhatsApp group instead of the chat? Because I'm afraid that the Zoom meeting chat might get lost. Sorry, just write it again in the group, yeah? . .
'Oke, Mas. 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 'Oke, Mas.
Yeah, also write how many times you answered. And can anyone answer this question? If there are no answers, I'm gonna put on a whiteboard. Oh, okay, Rafa mo no ba? Okay, okay. Wait. Okay, guys. I need to do it now. So, okay. Previously, we already got the Vy squared is equal to 1,000. Technically, because it's squared, it's meters per second squared, but so the Vy would be 31.62. So now all we have to do is get the Vx, which is equal to V null cos theta, which is 20 cos 30. This is equal to 17.3 meters per second. So now all we have to do is find the V. Let's just make it V final, which is equal to Vy squared plus Vx squared, which is equal to 31.62 squared plus 17.3 squared, which is equal to 35.8 meters per second. Any questions? So this is the speed of the stone just before it hits the ground. Just to give you a little bit more perspective, you can also do this. Vty is equal to V null y minus gt. So this is 10 minus 10 times 4 point, tadi time-nya berapa? Kita dapat time-nya itu 4.16. I have to get a calculator. This is equal to minus 31.3. Then you plug it into this. This is actually 6.2. And then you get the same answer. I'm gonna close the whiteboard now, okay? Okay, now that we're done with chapter 2, let's move on to chapter 3. Oh, I actually did the notes in Bahasa for chapter 3. I'm sorry, because there was another class that asked for Bahasa. If your friend doesn't understand, I'll send him a translated version maybe on Monday, okay? Yeah. Is anyone here familiar with Newton's law? There are 3 Newton's law. There's the first, second, and third. Can anyone tell me something that they know about Newton's law? You can pick. You want the first, second, or third. Just tell me something about it. Anyone?
About first Newton is when you move things, it will move until someone stop it. Something stop it. Was it?
Okay. Yes. Okay, now Farhan.
The time rate of change of the momentum of a body is equal in both magnitude and direction to the force imposed on it.
The apa? Sorry, putus.
The time rate of change of the momentum of a body is equal in both magnitude and direction to the force imposed on it.
Okay, yes, that is also correct. Rafa.
Okay, I want to explain about the third Newton's law, which is when a force works on an object, there's also a force that works on the opposite direction.
Yes, that is also correct. So I will review it a bit. The first law of Newton's first law, benda diam akan tetap diam. So basically, if there's no force acting upon an object, that object will stay in its current condition, whether it's moving in a constant motion or it is not moving. Understand? Okay. Next, Newton's second law. Now, I haven't actually read a literature on this, but if we're talking about Newton's second law, the correct form is not F equals ma, but the correct form is actually Fa is equal to F over m. But to make it easy, I use this usually. But just keep in mind that one of my teachers back in high school said that this is the correct form of Newton's second law. So basically for Newton's second law is when a force is being acted upon an object. So what happens in Newton's second law is that either an object accelerates faster or it slows down, or it decelerates, basically slowing down until it's put to a stop. Now, Newton's third law, every action has a reaction, but the reaction is in the opposite direction of the action. So this is an example. Let's say you punch a wall, you give it a force here. There's gonna be a reaction like that. As simple as that. Oh, and oh yeah, I forgot, since we're already in the third chapter, dinamika. The difference between kinematics and dynamics is that in this chapter, we will actually study what is causing the object to move. Like, when I push this object, when I give it force, why is it moving like that? But when we were talking about kinematics, when we threw a ball and it made a parabolic motion, what we only want to know is like the position at a certain time. We want to know the speed at a certain time. So it's not really talking about like, so why did, why, what force caused that ball to make a parabolic motion? No, we're not studying that in kinematics, but we might study that in dinamika, dynamics. So one thing that is very, very identical in this chapter is free body diagrams or diagram benda bebas. Ada yang tahu nggak? What is a free body diagram or diagram benda bebas? Anyone know? I am 100% sure that you have done this in high school. You've made a free body diagram before. You might just not know that it's called a free body diagram. Yes, Ardino.
A diagram which shows the acting force, which direction it is going.
Yes, so a free body diagram is a diagram that we use to analyze the forces acting upon an object, whether it's friction or the force we use to push or pull something, or it's the normal force or the gaya berat, anything like that. Yeah, we have to analyze everything in a free body diagram. Also like tegangan tali, tension. What else? There's actually a lot, but we'll stick to the basics today. Nothing too hard. Yeah. Let me go. Wait, do you guys know how to make a free body diagram yet?
Not yet.
Not
Kinda.
yet? Okay, let's start with a simple one then. Yeah. If anyone can, what's it called? Can help me out here? Please raise your hand. Yeah, oh wait, I have to make a whiteboard. Whiteboard. Yeah. Hey. Wait, let me draw first. Mm, can anyone draw a free body diagram of this? And analyze it using Newton's second law. Anyone know how? If you're gonna write it, raise your hand, yeah, Adinda Soraya. So I can what's it called? I can note your name. Anything you answer gives you extra points, yeah. Even if it's the simplest of questions, I will give you extra points. Oh, and include friction, yeah. Friction or gaya gesek kalau misalkan lebih familiar. If you can do it, please raise your hand. Nih Adinda udah coret-coret. Adinda lagi coret-coret tadi.
Iya, Mas.
Oh, enggak, itu kamu kan coret-coret.
Iya.
Itu dulu apa namanya biar bisa dicatat namanya.
Oh,
Nah, coba sekarang itu ada gaya geseknya. Gaya geseknya kemana?
ke kanan.
Gaya gesek, gaya
Terus-
gesek.
Oh, kiri.
Ya, coba digambar gaya geseknya. Oke, ntar deh. Nih aku koreksi dikit. Gaya geseknya jangan dibikin F ya, karena nanti kalau misalnya F, if you make it F, the assumption is that it's equal to the pulling force here. It's equal to this when it's actually not. So usually we make friction as F S. S is for if it's not moving yet. FK if it's for a moving object. But for now, just make it F. F coba diganti jadi F kecil. Make it small f. Okay, now analyze it using Newton's second law. You can analyze it for the y-axis and the x-axis. Bisa nggak analisisnya?
Itu yang pakai kayak cos sinus gitu.
Karena ini bidang lurus, nggak ada. The just divide it into two parts. Do first the x-axis, and then do the y-axis. This shouldn't be too hard. Ini Gabriel, ini bisa.
Ya, mau coba.
Boleh. Adinda
So,
udah gambar tetap ngelis nama ya.
Okay.
so for the x-axis, the forces that are working on the x-axis, there's the force to the right and the force of friction to the left. So the force to the right will get subtracted by the force by the friction going to the left. And for the y-axis, the weight is going to go down and the normal is going to go up, but then the magnitude of the normal is going to be the same as the weight, but only different direction.
Yes, that is correct actually. Can you do it on the whiteboard?
Lagi nggak pakai mouse, Kak, jadi susah.
Oke, ya udah kalau gitu aku nggak apa. Okay, we will look at the x-axis first. since the movement is all to the x-axis, fx is equal to m1a. Please rename your name ya for Zoom. Ini siapa nih? Pilar Idaman Mertua. Tolong di rename ya. Now we have fx. Fx is f minus f equals to m1a. Now, if you guys don't know yet, friction is equal to static coefficient, or in this case, since it's moving, it's coefficient dinamis times the normal force. So let's just make this as Fk, which basically means that it's a moving object. So it's equal to this. Now we take a look at the y-axis. Since there's no movement on the y-axis, you can just put it as 0. So in this case, no, not W, M1G or W. Wait, this is equal to M1G minus N is equal to 0. M1G is equal to N. Now you can substitute that value, F minus this, and this is M1G, M1A. Now what you have is F minus, sorry. Actually, let's just keep it like this. Let's solve it for the coefficient. F minus M1A is equal to this. Now we can solve it for this. It is equal to F minus M1A over M1G. Now it depends on the question, of course. Sometimes this is given and you have to look for this, or sometimes A is given and you have to look for this. It really depends on the question. Yeah. So it's not always like this. It depends on what is given and what you're asked to find. Okay, so this is for the bidang datar. By the way, you guys can scroll down the whiteboard in case you didn't know, yeah? So if you can't see my writing, just scroll down. Now
Mas,
let's move. Yeah.
sorry, mau tanya. Itu buat yang apa namanya? F kurang MK kalian itu buat koefisien friction kinetik ya, Mas?
Yes, kinetic friction coefficient.
Oh, jadi jumlah friksi kinetik itu berbanding lurus dengan massa dikali normal force-nya.
Bukan massa, itu mu. Mu itu ini nih. Ini ada
Oh,
mu,
mu.
ada M. Mu ini
Aha.
koefisien gesek. Ini M tuh massa.
Oh, oke, oke. Iya. Oke, thank you, thank you.
Okay, so let me clarify this. This is not mass. That is a coefficient for friction. There's static and kinetic. Static coefficient is for when you're calculating the friction for an object that is at rest. But if you're talking about the kinetic coefficient, it's for an object that's moving. And always will the static one be bigger than the kinetic one. This is always. Actually, does anyone know here why this is bigger than this? And always, not once or twice or 3 times, but always, in every case, is the static coefficient will be bigger than the kinetic coefficient. Anyone know why?
Karena yang coefficient kinetik itu dia bisa jalan. Kalau yang statik nggak bisa jalan, jadi harusnya lebih kecil. Karena statik bikin bendanya jadi nggak cepet.
Ya, benar. Tapi gampangannya gini. Which is harder? Is it harder to push an object that is already moving or an object that is at rest? An object not moving. Which is harder?
Not moving.
Yeah, that is why static coefficient is always bigger than the kinetic one. And also keep in mind, this has no dimension because this is equal to the friction over normal force, which both have units of Newton. So this is basically no dimension. It's just it's really just a coefficient. Any questions? Okay, we'll do one more. Yeah, one more. What time should you guys end? 5:30 ya harus selesai ya, atau 5:20?
It's actually 5:20.
Oke, 5:20 ya. Ada satu yang mau aku cover sempet ya. Ya udah deh. eh aku cover satu yang agak ribet ya. Okay, I'll just do this for you. You guys can take notes because if I ask you to do it, we're not gonna have enough time. First, let's analyze the left side or mass one. You're gonna have gaya berat ke bawah and normal force, and you're gonna have friction. And then you're gonna have tension from both. And for this one, for the second mass, you're only gonna have weight going down. So let's take a look at the y-axis of the first object, which is equal to 0. So we know that this is equal to this. Now let's take the look at the x-axis. This is equal to T minus friction, tension minus friction, equal to mass 1 times what's it called? Acceleration. We know that this is positive because let's just assume that this is bigger than this. So we know that movement is towards M2. Now that we're done with the first object, let's take a look at the second one. See, this is equal to M2A. Fy2 will be W2 minus T2 equals M2A. and the x-axis of it will be 0. Now in this case, since it is on one rope, the tension of T1 will be equal to T2. Now that we have that, let's solve it for T1. T1 is equal to, wait, this is T1. I forgot to write it. This is T2. T1 is equal to M1A. Whoa. Sorry. And T2 is equal to this. So since this is equal, just substitute the values. And M1A, and as you know, friction, you can state it as this. This is M2 times G. Now let's substitute the normal force, which is equal to M1 times G. And now what you can do is solve it for this. Now this is going to be equal to M2G minus M2A over M1G. Now you can also solve it for acceleration because it really depends on what the question is asking you for. But if you want to solve it for acceleration, you're gonna get this. Okay, pas banget waktunya. So now for your extra work, you guys can do this or you cannot. It's really up to you. Yeah. Here, nanti screenshot ini ya. Ini non-mandatory. Ini cuma buat tambahan nilai kalian doang. And to help you understand, of course. Make the free body diagram of these two systems. Where the force is here. And also do one like one more like this. Non-mandatory ya, ingat ya, non-mandatory. Just do it if you feel like you want to or need to. Nggak cuman free body diagram ya. Free body diagram and analysis. I'll take a screenshot. Okay. This is non-mandatory. Please make a Google Drive, and submit it by let's say Wednesday next week, yeah. Wednesday next week at 6 p.m. 18:00. Make a Google Drive and don't forget to send it to me. Okay? Understand? Any questions? Okay. Since it's already 5:20, thank you everyone for already coming to this class. I apologize if there were any mistakes or any words that offended you. Hopefully we can meet again soon. Oh, and don't forget to do your report for your practicum. If you have any questions about it, you can ask me. I'm also an assistant. If you have any questions about physics or anything about outside of physics, even about campus life or anything, you can ask me. Hopefully, this is my last year here. So if you have any questions, please do ask. And hopefully we meet again soon. Oh, and good luck on your midterm soon. And don't forget to study for your midterms. Thank you, everyone. I will end the meeting. And don't forget to do your assignments. Thank you, everyone.
Okay. Thank you, Kak. Thank you so
Thank
much.
you,
Thank
Mas.
you, Mas.
Thank you, Mas.
Thank you,
Thank you,
Mas.
Mas.